Hello viewers, you are welcome to another series on quadratic equation. In this lesson, we are going to learn the most easiest way to proving the quadratic formula using the completing the square method. With that being said, let's go to the board. Okay, what we see on the board is generally how we represent a quadratic equation. So with this expression or with this equation, we can actually derive the quadratic formula. The first thing we need to do is to take this constant c to the other side of the equation. So we have ax squared plus bx is equal to minus c. Of course, when positive c moves over the equality sign, it becomes negative c. Now the next step we do, that's step 2, we divide both sides by the coefficient of x. And here, the coefficient of s squared. And you can see clearly that the coefficient of s squared is a. So therefore, we divide both sides by a. So we're going to have ax squared upon a plus b upon ax is equal to minus c upon a. Of course, this will go without with this. So we have s squared plus b upon ax is equal to minus c upon a. Now step 3, what do we do in step 3? We pick out the coefficient of x, we will divide it by 2 and we square it. It is very clear that the coefficient of x here is simply b upon a. So we pick out b upon a, we will divide it by 2 and we square it. That's the rule in step 3. So we pick out the coefficient of x, which is b over a, we will divide by 2. But I'm not going to use this division sign because I already have a fraction here. So I'm going to write it as divided by 2 as this, divided by 2 as this. Okay, this is simply divided by 2 and then we square it. Okay, to simplify what is here, we have b over a, we change the division sign to multiplication and it will make 2 to be inverted. So we have 1 over 2 because this is like 2 over 1 here, and of course we put our square. Of course, b times 1 is b and a times 2 will give me 2a. Then we have all squared. This is what step 3 will help us get. Now with this term here, step 4, we'll add this term to both sides of this equation. That's step 4. We simply add this term to both sides of this equation. So therefore we have x squared plus b upon ax. We add this term, which is b upon 2a all squared equal to minus c upon a plus this time again we have b upon 2a all squared. This is step 4. Now step 5, you really need to come closer to your screen to understand what I'm going to do here in step 5. Step 5 is very, very critical, so just look up. Now if you look at this left hand side, this is the left hand side of this equation. If you observe clearly, the extreme terms in the left hand side are squared. You can see s squared and b upon 2a squared. So because of this, I can be able to write this expression in its compact form or in its factored form. The trick is that I'm going to open up a bracket, I'm going to open up another bracket, I'll close it with a square. Now you see this guy with the square, I'll bring out the term without their square and I'll bring out the extreme terms without their square. Then the sign that will be here is the sign of this guy. So this sign falls down to this place. Now this is simply how to write this expression in its compact form. Now I want to tell you the good news here is that if you expand this, you're going to get this. So that is how to do it. You can go and check it out yourself. So equal to minus c upon a. Then of course b squared is simply b raised to power 2 and 2a squared is simply 4a squared. Of course 2 raised to power 2 is 4 and a raised to power 2 is a squared. So this is how to get to this point. Now let's move over to the other side of the board. Right, you can see in this right hand side of the equation we have fractions term here. So if I want to simplify this fraction, I can also write this as b squared upon 4a squared minus c upon a. Of course, it's the same with this. I've not really done anything serious here. I just decided to change their positions. Here is positive, it's still positive. So minus c over a is negative, it's still negative. So no really much which we've done here. So the next thing we do, we take the LCM of the denominator. The LCM is 4a squared. That's the LCM. And 4a squared divided by 4a squared, we get 1. 1 times b squared is b squared. So 4a squared divided by a, we're going to have to like 4a squared divided by a. Of course, one of the a we cancel out, so we have 4a. Then 4a times c will give me 4ac. So that's what we have in the right hand side. But we will not forget to put our other side of the equation, which is x plus b upon 2a all squared. Now the next natural thing we do, we try to remove the square root here. So we have x plus b upon 2a is equal to plus or minus square root of b squared minus 4ac over 4a squared. Yes, just like we are squaring both sides. When you square this side, it will cancel out the square here. And when you square this side, this is what the result will look like. Okay, now hold on, let's clean the other side of the board. Now, because from the rules of solve, these square roots can be separated. So I have something like plus or minus square root of b squared minus 4ac over square root of 4a squared. So this can also be written as plus or minus b squared minus 4ac over square root of 4 is 2 and the square root of a squared is a. So we have 2a as our denominator. So we have x plus b upon 2a. Okay, if you're very familiar with the quadratic formula, you will know that this thing is already taking shape. So the next thing we do, we take out this 10 to the other side of the equation. That's collecting like terms. So we have x1, 2 is equal to minus b upon 2a plus or minus root of b squared minus 4ac upon 2a. Now, since they have the same denominator, we can go ahead and plus or minus the numerator. So we have x1, 2 is finally equal to minus b plus or minus root of b squared minus 4ac all over 2a. Yes, ladies and gentlemen, this is the quadratic formula. Thank you for watching. Have a nice day. God bless.